in the real world applications, we need to find efficient ways to work on our data. Yeah. And many times, we need to consider when we have large amount of data we need to do processing, then the performance issue is very important. Yeah. So in these two case study examples, we need to use some special ways to speed up the performance significantly. Yeah. All right. The second case study. Yeah. Last time I gave you the background description. Yeah. So here I just recall a little bit. Yeah. All right. So the project, it's a class project. So that's the simulation. Of Google Maps. Yeah, all right. We know Google Maps in this application, large amount of map data needs to be processed. Yeah, although that huge amount of data is stored in the database. Yeah. But the question is, when you need to search in that big database, how to get a very fast search performance? That's the main issue, right? That's the main issue. Yeah. Here we do simulation. Yeah. So in the classroom, we know the best we can do. Find the simplest way to do the simulation. Yeah. Yeah. The main purpose, so let the students to learn the main algorithm, the main idea to design an efficient algorithm. Yeah. So here let me describe, just to recall. Yeah. First, we need to simulate the Earth first. So I use a big rectangle to represent the Earth. Yeah. Although not a perfect representation, we know the sphere, right? The surface of sphere, that's the shape of the Earth. Yeah. But here, for a simple simulation, it's good enough. Okay? Yeah. So you just imagine large area, okay, containing everything. Yeah. Then we also need to simulate a local region, because the map data is loaded based on the local regions. Yeah. Yeah. So the user, usually when the user try to search, find a interesting place, location, place to go, only a portion of the map data needs to be loaded. Yeah. So we only load that small portion of the data. Yeah. So for that consideration, so we need to simulate local region. Right. So each local region we use a triangle to simulate. We know triangle is a simple geometric figure, right? Yeah. 3 vertices. So each triangle, we only need to know the coordinates of 3 vertices. That's good enough. Okay? So the coordinates of 3 vertices. All right. To identify one triangle. All right. And in the real world situation, one triangle, yeah, so we imagine corresponds to one zip code. Zip code. Okay? Yeah. All right. Yeah. Then, in order to simulate large number of local regions, so we need to divide this big rectangle as a partition of triangles. Yeah. Partition of triangles. Okay? We need to do that operation. So partition. All right. So what we need to do here, partition of the rectangle by triangles. Yeah. So we call this step triangulation. Triangulation operation. Okay? Yeah. But we rely on some existing function to do it. Yeah? Because if we need to do it using our own algorithm, too complicated, right? Yeah. So the good thing is, yeah, we can use MATLAB function. We apply a suitable MATLAB function on this big rectangle, yeah, and we pass some parameters. Here I want the 1 million triangles. Okay, so we pass that 1 million parameter to this triangulation function in the MATLAB. So the MATLAB generated data, triangulation data. Okay, all right. So this function generate, generate the triangulation data. Oh, yeah. Something, not quite right. Data. Okay? Yeah. Yeah. MATLAB, the data is given in the matrix format. Yeah. MATLAB, so yeah, some of you may heard of that. We know it's a very important education and even in industry, very important software, MATLAB. MATLAB, then MAT, M-A-T, represents matrix. Okay? Matrix. MAT refers to matrix. All right? So the data format is given as a matrix, rows, columns. Yeah, that's the generated matrix format. So the data matrix form all right. But that matrix form contains two portions. Two top part and the bottom part for two different types of information. Yeah. All right. Yeah. So the top part, yeah, like this. Okay. All right. All right. The top part, vertex information. vertex information. Vertex information, okay? Yeah. Yeah. Coordinates of each vertex. Yeah. Vertex 1, 2, 3. Yeah. So each vertex, two numbers, right? Yeah. X coordinate, Y coordinate. Yeah. Comma, Y, separated. Okay? Yeah. Oh, yeah. Then, one by one, a list of vertices. Yeah. And each vertex, there is a number, vertex number. First, second, third, 1, 2, 3. So long list of vertices. Yeah. All right. Then, the bottom part, that's the connectivity. Yeah. How to connect those vertices. Yeah. So each triangle, you need to connect 3 vertices, right? Yeah, 3 vertices. Yeah. So the bottom part is the connectivity information. Connection information. Connection information. Okay? For example, vertex 1, vertex 2, vertex 3. That's the first triangle. Okay? Vertex 4, vertex 2, vertex 5. Here, I'll just give you some simple example. Vertex 5, and so on. Okay? Yeah. Each triangle is represented by their corresponding vertex numbers. 3 corresponding vertex numbers. Okay? Yeah. So that's the data. Yeah, in this way. So after I get this data, I post it. Yeah. Several megabytes, yeah, because 1 million triangles, data, size, pretty large. Yeah. But it's a text data. Okay? So the students can use text editors to view the data. Yeah. Then, after you understand the structure, next, we need to do processing. All right. So the given location, so here, next, the input is the given location. Oh. Given location, 1 point. Okay. 1 point, yeah, let me use 1 point represented by its coordinate, A, B coordinate. Okay, all right. Yeah. So given any point inside this triangle, how to find one of the triangles, yeah, one of the million triangles that contains this point. Yeah, that's the simulation problem. Yeah. Yeah. That's the simulation problem. Okay, all right. Now then, to solve this problem, if you need to search, do the search, go through from beginning to end, all these 1 million triangles, very time consuming. Very time consuming. Okay? Yeah. Yeah. So let's say 2 minutes. Yeah, here I just use some approximate amount of time. Yeah, 2 minutes to, because for each triangle, you need to plug in a formula. I provide that formula to the students. So you plug in, you find a value. If the value is positive number, then the given point is inside the triangle. If it's a negative value, the point is outside triangle. If it is 0, the point is on the edges of the triangle. Okay? Yeah. Yeah. But when you use the brute force method, you search all the triangle, use the sequential search here, right? Here there is no order. Yeah. You just search your data, first triangle, second triangle, then plug in the formula from beginning to end. Yeah. Very time consuming. The next question. the main idea of the speed up algorithm. Yeah. How to do the fast search. Yeah. The first idea, we need to do pre-processing. Yeah. So here's the idea. We do pre-processing idea. Pre-processing idea. Yeah. Before the user submit a search request, yeah, you can spend your time to do data preparation. Okay? Yeah. Yeah. So here the trick is we want to do a lot of pre-processing work, yeah, to generate derived data. Remember, we have that concept. We generate derived data. That derived data can help us make the later search operations much, much faster. So here the question is, how do you create the derived data? Okay? How to create appropriate derived data? Yeah. Some smart idea should be used here. Here, I give you the main idea, how to prepare the derived data. We use idea called localization idea. Okay. So the idea, if I use one word to represent the main idea, so we call it a localization. Yeah. Then I explain this idea. Yeah. So what is this? The meaning of the localization idea. All right. Before we do this pre-processing, in the brute force method, when you do the search, you do the global search, right? Yeah? Why your search is so slow? Because you do global search. You need to look at 1 million triangles. That's the reason the search is so slow. Now, our idea to make it faster, we do not do global search. We want to do local search. Okay? We want to reduce the search region significantly. Not 1 million. Can we reduce to 10 triangles? Can we reduce from 1 million triangle to 10 triangles? Okay? If we can reduce 1 million, that's the global region. If we can reduce to a small region, then we do not need to look at the, everywhere on Earth. We only look at one small region on Earth. Then we only do the search in that small region. We can do much faster. This is idea. This is called a localization idea. Okay? All right. But how do you do localization? Yeah. Here, let me show you. Let me draw a simple diagram to show you the localization idea. All right. So here, I do localization. All right. Yeah, whatever. So here, I can leave it here. Yeah. I can leave it here. All right. Now, when I do the localization, I do some simplest partition on Earth. Earth is too big. Okay? Global. Now, I want to divide the whole surface of the Earth into smaller regions. In this triangle, I draw grid. I draw grid on this rectangle. How about that? That's easy, right? Yeah. The grid, the width, height, same. Okay. The simplest grid. Yeah. In order to make our processing easier, draw grid. Okay. Yeah. Same width, same height. So each local, this time, each local, the smallest local portion, we want to use as our search unit, basic search unit is one square. Small square, okay? That's our search unit. 1 unit of the area we use to do our search. Okay? All right. All right. Then let me explain the last step. Last step, you get the idea, insight. Right. Now, let me ask you. After I draw the grid, I tell you width, height, rectangle width, height. Okay? So, perfect. Given a point, coordinate A and B, point. Yeah. If I ask you the question, which square contains this given point? Is it easy to get it? Here I ask you square. Which square contains the given point with x, y coordinate? That's easy, right? Yeah, because you just do division, right? Yeah. A, you divide it by the width of the square, a side of the square. Yeah. Division, when you count horizontally, which number of square it should be located. When you count vertically, which number of the square should be located, right? So you can, the first step, given this any point in this rectangle, you can do by some simple calculation, you can immediately detect which square contains this point. All right. Yeah, that's the first step. After that, when you make the search, do you only need to search triangles that have intersections with the square? If a triangle has no intersection with the square, do you need to try it? Think about it. Only when a triangle has intersect with the square, then there is a chance the point could be located in that triangle, right? If a triangle that has no intersection, okay? If a triangle, let's say, some triangle has no intersection with the square, do you need to plug in this point into that triangle? No intersection. No chance. Yeah, must be outside that triangle. Yeah. So now you need to know what are those triangles that intersect with this square. You need to know that information, right? If you know that information, then because that number usually not too many. Not too many. A small square, how many triangles have intersections with that one relatively small square? Not too many, right? 10 something, let's say. Yeah, so a relatively small number. So you need that information. So here, the information. For each square, you need a list of triangles that intersect with the square. That information, you can do the calculation in the pre-processing, right? Because that calculation, you can use a lot of time to calculate that before the request is submitted. That's the pre-processing, okay? All right. So then you generally derive the data. What's the derived data? Each square is associated with a list of triangle numbers. Yeah. Triangle, you have the first triangle, second triangle, each one has a number, right? Number 1, number 2. Yeah, triangle also has a list of numbers. And 1 million, okay, triangle. You have 1 million triangles. So each square you associate it with a list of triangle numbers, okay? So after you generate that data, then you are ready to do the, real search operations. Real search operations. Yeah. Then, for the real search, after user enter two coordinates of 1 point, now you run your algorithm. Yeah. First, calculate which square contains this point. After you get it, then you search your database to retrieve a list of triangle numbers that intersect with the square. Okay? After that, you only need to plug in the coordinates of this point going through this relatively short list of triangles, right? Yeah. Yeah. A short list of triangles. Yeah, that calculation time is pretty fast. Yeah. So in that way, yeah, so you can output the final triangle number that contains this point very fast. Yeah. The final result has click the button 0.2 second. Okay? Things like that. 0.2 second. You can get an answer. Yeah. So this case study example, yeah, shows you how can we make some very expensive operation very fast. Yeah. If you use the brute force method, extremely slow. Yeah. Now here, see the main ideas. Yeah. Localization idea. Okay? Yeah. Pre-processing idea, these two ideas. First, you need to do localization. Yeah. After you do localization, you need to do another step we call the registration. Yeah. Because the pre-processing is a high-level description, right? Very general high-level description. But low-level, yeah, low-level, going down a little bit, yeah. What kind of specific pre-processing you want to do? Yeah. Here we call the registration. Yeah. What kind of registration, all right? Each unit square, we need to associate it with a list of triangles. This kind of calculation, so we call it registration. Okay? Yeah. Yeah. To localize in this way, we can change from global search to local search. Why we do that? So the main idea here is change from, it's very sensitive. Next I need to find a way. From the global search to local search. That's the main reason why we can solve this problem in a so efficient way. Yeah. Yeah. Very efficient. Yeah. Okay? Yeah. Simulate the Google Maps search operation. Yeah. Here you can see if you really need to work on the map data, yeah, you can do registration, right? Yeah, the Earth, you partition the Earth into, many relatively small regions. Okay, yeah, longitude, latitude, right? Yeah, yeah, to very much smaller region. Then you do registration. Each block of region, then you need to find what are those local regions, zip code. Okay, local regions corresponding various zip codes, yeah, intersect with this, unit block region. Okay, yeah? So that number much smaller, right? That number, very relatively small. Then when you do the search, you only search those much shorter list of local regions very fast. Okay? Yeah? Yeah. Try to learn, try to understand this algorithm. Yeah. How to make the real world operations much faster. Yeah. Yeah. Probably, so sometimes you may encounter the situation that you need to use this idea. Okay? Yeah. Yeah. All right, so this is the second example. First example, yeah. So next week, I try to find some time to talk about that Google search engine case study example. All right, yeah. Next, yeah. We have another slide after this one. Yeah, let me finish that slide. Responsibility for control dependency. Here we know we cannot eliminate all the redundancy. Yeah. We allow some redundancy, but the redundancy must be under our control. So the controlled redundancy. Then who should do it? Here, who here refers to DBMS, right? Refers to programmers, yeah. Refers to DBA people, yeah. So many different users, yeah. Here, someone is responsible for maintaining controlled redundancy. Yeah. All right. So here, this sentence I copied from our textbook. Yeah. The original sentence. Yeah. I want to make some comments on this sentence. DBMS should, underline, have the capabilities to control this redundancy in order to prohibit inconsistencies among the files, but it couldn't. Okay? Although it should have that capability because it's too hard, too complicated. Yeah. Yeah. Too complicated. Okay? Yeah. Yeah. But in order to make DBMS to do this kind of work, we need to write programmers to tell DBMS how to do it. So that's our responsibility. Okay? Yeah. DBMS cannot do it automatically. So we need to do a lot of work to help DBMS to do it. Yeah. All right. Yeah. Yeah. So this is from textbook. What DBMS can do? Yeah. Enforce certain constraints. Yeah. But those constraints, very simple. DBMS can only apply simple constraints. If the constraints are too complicated, then we need to write programs to do that. Yeah. When we want to enforce very complicated business rules, then we need to write, let's say, stored procedures to tell DBMS how to enforce those complex constraints. Yeah. So here, that's the simple constraints. Okay, all right. Cannot enforce business rules directly. Yeah, yeah. So usually here, when we have, so here we should say this way: when we have relatively complicated business rules, yeah, it cannot. But some business rules very simple. Then we can define constraints to implement those very simple constraints. Yeah. How to define module 3? Yeah, I will show you how to define simple constraints. Yeah. Yeah. All right. Yeah. So then the answer to this question, that's the our responsibility of application programmers. Yeah. So we need to do a lot of work. Okay, yeah. Typically we use stored procedures to give detailed instructions to DBMS to enforce complex business rules. Yeah. That's the conclusion. Yeah. All right, so we finished part B, but with one case study left. Okay, yeah. So for the next week, yeah, I'll find some time talk about Google search engine, the main idea. Yeah. All right, let me jump to part D. D.1, virtual tables, this concept. Yeah, so another useful concept. Yeah. View of a database here, this view concept. Yeah. In our database context, this view has a special meaning. Yeah. Yeah. Different from our general understanding that the word view. Yeah. So in this concept, it refers to a special object view. So what's that special object? It is related to table. You know table concept, right? Table. Used one table to store data. Okay, that table. So this view is closely related to the table concept. Yeah. So let's study this concept. Why we need it? Yeah, you already have a table. Why you need that view? Similar view concept. Yeah. There is some good reason. Yeah. All right. Different users may require different perspectives on the same data set of data. Yeah. Here, you imagine in our real-world applications, we have a large database containing large number of tables. So the data stored in those tables, we treat it as original data, original business data. Yeah. Then, this big database, we need to use it to support many real-world applications. Yeah. 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 Many different users, they want to retrieve data from this database, but in different formats, right? Yeah? In the different users, they want to retrieve the data formatted differently. Yeah, that's very common. And you can imagine there are a large number of users. They need to view data in many different ways. All right. So this is the situation. Yeah. Yeah. Under this situation, we need to consider how to manage our data efficiently. So there is a performance issue. Yeah, there is a performance issue. Yeah. All right. So we need an efficient way handling data. Yeah. What do you mean efficient way handling data? All right. Let me give you more information to understand. Yeah. So here we need to use the virtual data concept here. Virtual data. Not physical data. Physical data refers to original business data. Original business data. That's the physical data. Yeah. But here, yeah, we use virtual data. Okay. Virtual data here, it means the data is not stored physically on the hard drive. Not stored physically. Okay? Yeah. Virtually, right? Yeah. So it is not stored. Yeah, actually, on hard drive, it is not stored. So virtually, that means the format information of the data is stored. Only format. Okay? The format of the data stored. But The real data part, the physical part, not there. Not there. Okay? Yeah. Only stored specific format. Yeah. So what's that? Yeah, let me explain more. Yeah. No physical storage for the data. Yeah. Can save a lot of space. Okay? Yeah. Think about yeah. Large number of users, they want to view data differently. So if you store all such data on your hard drive, you need to use too much space, right? Yeah. So first, you can save a lot of storage space. Yeah. Yeah. All right. Derived from physical data. Yeah. So definitely, you need to use many tables, multiple tables. There, you need to define operations to generate required data for your users. Yep. So you need some special way to arrange the data. So you need to find special operations to generate the required data for your users. Okay? Yeah. Yeah. All right. All right. So the data derived from physical data, yeah. But you do not make your derived data physical. Okay? You do not make your derived data physical. You make your derived data virtual. Virtual. Okay? Yeah. So you can save storage space, could be stored physically if needed. Yes. So you have the option. Okay? Yeah. You have the option. If you can justify it, if you really need to store this data physically, you can do it. Yeah. Just another command. You apply another command, you make it physical. That's easy. Yeah. If you have no good reason to do it, then save some space. Yeah. Do not do it. Yeah. All right. Here, let me explain another reason, so why we want to do this way. Why this feature, here. Yeah, let me complete this slide by another important information. Yeah. Think about. All right. Derive the data. Yeah, so here. You need to imagine how to derive data, right? Yeah. So derive from physical data by a sequence of SQL commands. Okay? So you need to write a list of SQL commands. Yeah. So you apply those commands one by one. At the end, you generate the derived data. Okay? Yeah. All right. So here the question is, after you generate, yeah, because this sequence of SQL commands could be time consuming. Okay? When you run, think about this, could be time consuming. Could be time consuming, yeah? Takes a lot of time, yeah? Because your data amount is so large, complex operations, yeah? Your users need to wait relatively long time for the result, right? Yeah. In that situation, how to improve your user's experience by speeding up this data generation step. You don't want your user waiting several seconds for the result of the derived data. Okay? So you want to give immediate response to your users. How to make it happen. How to make it happen. Yeah. All right. Yeah. The way to make it happen, because this block of commands, time consuming, the idea is avoid it. If you can avoid it, okay, then you do not need to use a lot of time. How to avoid it? Okay. Yeah. So you store the generated result as a virtual table. Virtual table, that's the view. Okay. As a view, you store it. It's a virtual table. You store it as a view. Okay. If necessary, you can store it as a table. That's the physical data. Okay. Yeah. If you feel, because this part, first, this part of the data is used quite a lot, quite often. Okay. Second, every time I run this block of SQL commands, very time consuming, I want to avoid it. Okay. To avoid it, how about I just store the results as physical data, table, physical data. Okay? Yeah. In that way, the next time you do not need to generate because you just retrieve physical data directly, much faster, right? Yeah. Much faster. Yeah. All right. But for the virtual data, here, for the virtual data, you store the results because you do not store data. Okay? So for the virtual data, you store the generating way. You only store the generating way as the virtual table. You do not store data. You store the way to generate it, how to generate it. Okay? That's what we call the virtual data. So you do not store physical data. You store the way to generate the data. Okay? So that's the commands. Yeah. Special way to to put your commands together that way. Yeah. Next time when you need the data, you ask a DBMS to run this block of commands, this whole block of commands. Okay? You can get the data. Yeah. But if running this whole block, if too slow, then a better way, you want to store that derived data physically, then you do not need to go through a long list of time-consuming SQL commands. You just retrieve the data directly. Okay? So here, yeah. So this concept and the situation, how under what situation we need to use this concept. Yeah. All right, so that's this view concept, virtual table view concept. Yeah. All right. Yeah. So now we can go to oh, sorry. Yeah, we're already in part D. Yeah. So let's go to the next one. Size of a database. The general. Database. There is a question. How large? Is there a size limit? Here we want to understand this question. Is there a size limit for a database inside DBMS? Yeah. So the answer here, give you the basic answer here. Yeah. For the general case, a database can be of any size and complexity. That means no size limit. Okay? No size limit for the mainstream DBMSs. Yeah. Mainstream DBMSs. Yeah. All right. Yeah. MySQL, Oracle, no size limit. Okay. All right. Yeah. Yeah. But for some special, not that big players, yeah, for some small players, yeah, then Microsoft Access, there is a size limit. We know it targets home business, right? Yeah, home business. Yeah. So then usually the data size is not very big. Yeah. Yeah. If you need a much bigger data size, then you should not use the Microsoft Access. Yeah. You can use MySQL. It's free, easy to use. Yeah. So if your data size becomes larger than 2 GB, yeah, one way you can do backup, right? Your history data, you can do backup. Yeah. Only keep the recent part of the data. So you can control the size. Yeah. Otherwise, if you feel not convenient, then you need to switch to MySQL, for example. Yeah. All right. Understanding query. Yeah, this word query. Yeah, we use this query word many different places. Sometimes the meaning could be different. Yeah. All right. The narrow sense. Yeah. So the query, knowledge, broader, narrow sense. Yeah. We mean data retrieval. Yeah. That's the query. Yeah. Query there, we retrieve data. Query, but sometimes we use it in a broader sense. That's any database accesses, including modifying data. So we can call all of them query operations. Yeah. Yeah. So based on the context, so you can understand the exact meaning of this word. Yeah. All right. Yeah, so that's the size part. All right. Next, D.2, integrity constraints in DBMS. Now we need to look at how to define some simple constraints. Yeah. All right. Integrity constraints. There are several very simple integrity constraints. Yeah. All right. Yeah, so here, we need to, in our table definition, we need to apply certain constraints. Yeah. There are several types, simple types. Yeah. We can do it easily in our table definition. Yeah. But some constraints, we need to do a little more work, then we need to do it after we define the table. Here, let me show you simple constraints. Who will enforce them? Application programmers. Yeah. So here, yeah. So DBMS, if we can make DBMS to do it, then we should make DBMS to do it. Yeah. If it's too hard for DBMS, then at the end, we need to do it. We application programmers, we need to write stored procedures to implement complex constraints. Yeah. All right. Now, give you the simple integrity constraints, several types. Yeah. All right. First, simple type, specifying a data type for each data item. Integer, right? String, date, yeah, so many different types, data types. Right? Floating point, right? Double, and many different data types. Yeah, so that's the simple type constraint. Yeah. In your table definition, you specify that kind of constraints easily, yeah, for each field. Yeah. So we will see some examples quickly. Yeah. Yeah. So the DBMS can do this part easily. So easy. Yeah. So we let DBMS do it. Then another constraint called referential integrity constraint. Referential. Yeah. Reference. Yeah. Referential. Okay. Yeah. So this part a little harder than the first one. Yeah. Because it related to the concept called the foreign key concept. Yeah. Foreign key concept. Yeah. So this concept we delay it. Yeah. 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 So at this point, so the basic idea is we need to consider the relationship between two tables. Yeah. In the first table, you need to refer a key. Foreign key, that key, yeah, so the key concept, later I will talk about the key concept. Refer a field that is primary key of the second table. So there is a primary key concept table, okay? Yeah. Because there are several concepts we need to use. Yeah. Yeah, but here, just let you know, this referential integrity is about this foreign key concept. So we need to define a foreign key. Okay? Why we define it? Because for data integrity. Yeah, later. Because there is a relationship between two tables. When we modify one data item, then we need to update because there are several other copies. We need to make the data consistent, right? Yeah. Integrity, consistent. So there are several other copies you need to update. Okay? So if you define foreign key relationship, the DBMS will do the updates automatically for you. Okay? Yeah. So that's the basic idea. Yeah. So, but later we will use one whole topic to explain foreign key. Yeah. Because this is a relatively hard concept we need to understand later. Yeah. All right. Yeah, but DBMS can do it. Okay. Yeah. Not too hard for the DBMS. Yeah. So a record in one file. File here we mean table. Okay. Yeah. So file. A table is physically stored on a hard drive as a file. So one record in one file must be related to records in other files. Yeah, multiple tables, other files. Multiple tables can refer, one record in one table. Yeah. Yeah. The primary key of one table could be used by several other tables. The meaning. The sentence means that. Yeah. But after we learn the foreign key topic, you can understand the sentence easily. Yeah. Here, too abstract. Yeah. Then another constraint called a uniqueness constraint. Yeah. Uniqueness. Yeah. All right. So the meaning is this. So you have a table. Okay? Yeah. In your table, you have many rows, and you have several columns. Okay. Now regarding the uniqueness, yeah. So here let's consider this column. Okay. All right. This column, sometimes we require the values of different rows in this column. The value must be unique. No duplicate values are allowed. Yeah. So two different rows in this particular column, they cannot have the same value. Sometimes we require that. So that constraint we call a uniqueness constraint. Uniqueness constraint. Okay? Yeah. And this special requirement, yeah, if this column needs this uniqueness constraint, then we call this column key. Because here you see that foreign key, right? You see that key, foreign key. What's the meaning of key? Yeah. So here, you know this key. Yeah. All right. So the different, but this foreign key has different meaning. So if you take out this key, if a field, so here, let's say this. If a field is a key, then it must have the uniqueness requirement. Okay? Yeah, but the foreign key is, different story. Yeah, because foreign key related to primary key of another table, that's very complicated. Yeah. So the meaning, when you do understanding, you need to look at two tables. Yeah. But here, this requirement, uniqueness constraint related to that key concept. Okay, so this field, it is a key column. Okay, it is a key column. Yeah. So so here the concept, key concept. All right, and the DBMS can enforce it easily if you define unique. So this particular column, you put a unique constraint. Then someone enter duplicate values in this column, the DBMS would reject it, because it violates the uniqueness constraint. So the DBMS enforces this constraint easily. Yeah. All right. Then the last type, the business rules. The business rules, you can have simple rules, right? Yeah. Sometimes your business rules are very simple. Okay. Yeah. For example, the range of age. You want to define the range of ages for your employees. Okay. Yeah. Employee, there is a specific range. Okay. Or department number has some specific range. That kind of business rules, very simple. Yeah. So you can write the constraint definition to make a DBMS to do it easily. Yeah. But you may have very complicated business rules. Yeah. In that situation, then we as application programmers, we need to write SQL code, store the procedures to implement, to enforce, to tell DBMS, follow this procedure to enforce business rules. Yeah. So that's the last type, constraint. Yeah. All right. Yeah. All right. So that's the this topic. Yeah. Then the last topic of part D, D.3, more on stored procedures. Database stored procedures, situations. Yeah. Resources are distributed on different machines. Here, we want to do, we studied this concept several rounds. Yeah. Yeah. So each round, we study deeper. Yeah. We go deeper and deeper and deeper. Yeah. So this round, we go another level deeper to understand stored procedures. Yeah. This time, we look at it from the application point of view. Yeah. Now we need to use stored procedures in some large applications distributed globally. Okay? Globally in many different locations. In that situation, we need to use stored procedures. And we want to see what's the benefit under that special situation. What's the benefit using stored procedures? Yeah, let me explain the main benefits in that situation. All right. Web application programmers are on a web server. Yeah. I drew some diagram before. Yeah. So here, let me just draw the similar diagram here. This circle in the center, that's our data center part. Yeah. So we assume, we have one location to hold the data service. Okay. Yeah. Data service, power, some big application distributed globally, okay? That kind of huge application. Yeah. So this is the data part. Oh, sorry. Yeah. Data center, okay, for example. Yeah. Then, for the features, application features of your big application, because you need to do a lot of special data services. So you need many web servers. So all these circles, each circle represents one web server, one location. Or you can say web servers in one location, one particular location. Okay? Yeah. All right. But you all need to access the same data center. Okay? Yeah. So on. Okay? Yeah. Yeah. DBS is running on a data server, yeah, data center. So that's a large number of servers. Yeah. Yeah. An efficient way. Yeah. So here, let us imagine. Yeah. We need to do a lot of data processing, right? Yeah. Yeah. So the whole application, yeah. In all those different locations, yeah, we need to run many different types of data processing jobs, right? Data processing jobs. Yeah. Some of the data processing jobs are heavyweight. So you need to very time-consuming data processing. And some data processing work, yeah, very fast, relatively simple, easy, fast. Yeah. So you have all those different kinds of data processing jobs. Yeah. All right. And here, in this situation, for those heavyweight or time-consuming data processing jobs, we want to use efficient way to do it. Time-consuming. Okay. The efficient way, we use database program modules, stored procedures. Okay. Modules, yeah. Each procedure we treat as a module. Okay. Data processing module. Yeah. So one block of code do some specific time-consuming data processing. Yeah. So yeah. So let me. Yeah. I need to stop quickly. Yeah. All right. Yeah. Yeah. So right. Yeah. So yeah. So the remaining a few lines. Let me leave next time. Next time I can finish in less than 10 minutes. Finish the remaining part. Yeah. Mainly about how do we apply stored procedures to handle our data efficiently. Okay. All right. Yeah. So just don't forget to check our homework number 1 in Canvas this weekend. Okay. Yeah. This weekend. Yeah.